I'm Biff Turkle. You see me in such fine quality chemistry educational videos as Chemistry and Molarity. Is there a similarity? And moles, moles, moles. It's all about moles. Okay, this is another part in the era of stoichiometry. Okay, nice big giant word for a fairly simple idea, but in order to find out what the stoichiometry is, you got to go back and check out a couple of the other videos. We talked about mole, and very briefly, what we're going to be looking at here is how do we go from grams to moles on this video. Okay? So when we look at something like grams, we're going to go ahead and let's take something that everybody desperately needs. Agua, otherwise known as wasa, otherwise known as lu, otherwise known as water. Yes, good old H2O. So, you know, if I happen to have 36 grams of H2O equals, well, how many moles do we have? Now remember, boys and girls, a mole, excuse me, I gotta get a calculator, a mole is a giant number. It's huge. It's like the chemist's dozen. Okay? And it's this huge, huge number, like 6.00 times 10 to the 23rd. Gosh, it's huge. Right. And that's why most people aren't going to be seeing that in the general public, because it's such a huge giant number. We're not going to have such things as a mole of Grandmaster C concert tickets. It's just not happening. Okay? If we had a mole of dollars, then every human being on the face of the earth would be a multi-millionaire. Yeah, Bling City. Okay, so let's look at this. We got going from grams to moles. We have 36 grams of H2O. How many moles do we have? How many of these chemists' dozen do we have? Well, in order to go from grams to moles, we're going to need to divide, and that's a very quick formula to look at. You'd say, okay, but what are you dividing? Well, we need to figure out that we've got 36 grams of water, but we got to figure out, wait a minute, how do we go from grams to moles? Well, we got to divide, but divide by what? Well, we're going to have to divide by how many grams there are in a mole of water. So we have to figure out how many grams there are in 1 mole of water. That's really what this is about. Okay? And if you go and do all your division, you'll notice that you would end up with mole as your final unit for the answer. So I'm just showing it to you. But now the question comes down to is, well, wait a minute. How do we get the grams per mole? Well, I did talk about that in the other video that you can check out, but very briefly, let's go ahead and let's take a look at this. If I break up my H2O into 2 hydrogens and 1 oxygen, which is what H2O is made of, I need to figure out, well, gee, how many grams are there in a mole of hydrogen atoms? How many grams are there in a mole of oxygen atoms? Where are we going to find out that information? There is something called the periodic chart. Now, you guys worked with it earlier in the year because we got to look at some really cool things like the symbols and all that. And the periodic chart looks something like this. And you may remember that we have pieces of information here. Let me maximize this for a moment. So, that looks a little bit better. Now I'm interested in looking at hydrogen. Well, hydrogen's over here, and notice there's the atomic number 1, which tells us how many protons there are in 1 atom of hydrogen. Yay! Okay, but is that going to help us out for stoichiometry? No, it's not. Now, how about the H? The element abbreviation. Is that going to help us for stoichiometry? Not for the numbers, but it does tell us what the abbreviation, the element abbreviation is. That's nice. The name of the element, okay, yeah. And then we have this 1.01. What's up with that 1.01? Well, it tells us two pieces of information. One, it tells us how much does one hydrogen atom weighs in atomic mass units. And some people are thinking, I don't get this. What do you mean by atomic mass units? Well, in the science realm, in the chemist realm, when they are looking at how much an atom weighs, they use carbon-12 over here as the standard for which we could measure all the other elements in there. And we said, okay, carbon-12 is 12 atomic mass units for one carbon atom. And here hydrogen is 1.01 atomic mass units. Now, you'd say, wait, I'm still not getting it. Well, the atomic mass units, again, 99.99999999999% of the public will never ever use or ever hear again. Never ever hear of it again. Right. Okay, so we're kind of out of options. What does that 1.01 tell us? Glad you asked, because this is where it becomes useful for us when we do stoichiometry. 1.01 is 1.01 grams to 1 mole of hydrogen atoms. So if I had that 1 mole of hydrogen atoms in the palm of my hand, it would weigh a little bit more than a gram. Ooh, not much. But in that not much, I have got a mole of hydrogen atoms, that giant, giant number we mentioned earlier about. If you don't know about that one, see a previous video. Okay, so I know that hydrogen is 1.01 grams. We got it here in the periodic table. Now let's take a look at oxygen. Well, if we look at oxygen here you got 16 grams. Okay, so now let's go back. So I know hydrogen is 1.01 and oxygen is 16.00. So we can add those up. Now, could I take the 1.01 and multiply it by 2 and add it to the 16? Sure you could. And I'm just showing you step by step how to do this. Yes, you can multiply this by 2. That's easy. Okay? So we're going to add that up, and it's going to be 18.02 grams per mole of water. Okay, so that means now we can go back and say 18.02 grams per mole of water. So when we look at it, we've got 36 grams of water. Okay, so 36 divided by 18.02, and we get 1.9977. Okay, well, they're going to round it up, so we're going to say 2 moles. 2.0 moles. So that's how we went from 36 grams of water to how many moles of water that we have, because we went from grams to moles, and grams to moles, you're going to divide. That's how you're going to do this. So we had 36 grams of water. We calculated, using the information on the periodic table, how many grams there were in a mole of water. So 36 divided by 18.02, and we get 2 moles of water. Hey, let's go ahead. Let's work through another one. Okay? Let's try another one. Let's see. And another nice cool part about this is that I can turn around and pick any molecule I feel like, because, you know, hey, it's kind of cool that way. Okay, so you know what? If I happen to have 125 grams of, let's try something else everybody knows about, CO2 equals how many moles of CO2? Okay, well, we know if we're going to go from grams to moles, we're going to have to divide. And again, what are we going to divide by? How many grams there are in a mole of CO2? Okay, what does that look like? Well, there's going to be 125 grams, and then we're going to have to figure out how many grams there are in a mole of CO2. All right. Well, what do we know about CO2? Well, we know that we have a carbon and 2 oxygens in there. And if we were to go and look at the periodic chart, we'll see carbon is 12.01 and the oxygen is 16. So I look directly at the periodic chart. for how many grams there are in a mole of something, I go back, I have 12.01 grams per mole. I have oxygen with 16 grams per mole, and another oxygen 16 grams per mole. Now I can add up the whole thing and say, okay, I have 44.01 grams per mole of CO2. So now I can go back up here and say 44.01 grams per mole of CO2. So let's clear this. 125 divided by 44.01 equals, and we have ourselves 2.84 moles of CO2. So that's what we have, ladies and gentlemen. Okay, let's try for one more. Let's try for one more example here. Oh gosh, let's do something a little bit more. Yeah, let's do sulfuric acid. Yeah, let's do that. So you know what, if I happen to have 15 grams of H2SO4 equals how many moles of H2SO4 are we going to have? Well, again, we're going to go, if we go from grams to moles, we're going to divide. Okay, so that means we're going to have 15 grams divided by however many grams there are in a mole of H2SO4. Now, we go back. How do we figure the grams per mole of H2SO4? Well, we have our periodic chart that we can go back and refer to. So let's take a look at this. I'm going to do this a little differently because now I'm going to kind of multiply some things. I know I have 2 of these H's, okay, and that's 1.01. Where did I get the 1.01? Right up here on the periodic chart. Not the whole number 1, the 1.01. That's important. Okay, so I know that's going to be 2.02. Now, I have an S. Well, I've got 1 times S. And what is S? Our sulfur. It's 32.07. Notice I go back to the periodic chart. Okay, 32.07. So that's going to be 32.07. Okay, so far so good. And now we have 4 oxygens. Well, we know it's going to be 4 times O times 16. And somebody's going to say, wait, where did you get the 16? I got the 16 from the periodic chart right here. Okay, the more you work with this, the more some of the numbers like hydrogen and oxygen, they're going to come pretty quickly for you. And then you don't have to sit there, I whip my screen back and forth, I whip my screen back and forth. Pretty soon you won't need to do that. Because some of that stuff you'll memorize it. Okay? Now 4 times 16 happens to be 64. And now I can go ahead and I can add the bad boy. And let me bring that up. So 9, 0, 2 and 2 is 4, 4 and 4 is 8, 3 and 6 is 9. So 98.09 grams per mole. So over here now, we figured out how many grams there were in a mole of H2SO4. So we have 98.09 grams per mole. So we're going to take however many grams we started with, which was 15, because that's what I gave at the beginning of the problem. And we're going to divide it by how many grams there are in a mole. So let me clear this bad boy up. And we got 15 divided by 98.09 equals, and I have, ladies and gentlemen, 0.15 moles of H2SO4. And there you have it. I've worked 3 examples with you guys on changing grams to moles. Okay? You need the periodic chart to figure out how many grams does a mole of something weigh. You're going to add it up to get what's called the molar weight or molecular weight or formula weight. Okay, just like you see here. And then you take the original mass in grams divided by how many grams there are in a mole of that item, and voila, you got yourself moles. And that takes care of it for this video. Hey, I hope it's been helpful to you guys. All right? Till then, take it easy.